K, where K is the 100 million euros, I pay. SI is the 120 million dollars I receive. And we said since there is no negative credit, I have a maximum zero value. We all agree on this?
Yeah.
This is the Black-Scholes. This is the price of an option. This is the price of a call option. Remember? S, K. And this 4/10 times sigma times square root of t is the linear approximation of Black-Scholes.
From the Taylor expansion?
From the Taylor expansion of Black-Scholes, yeah.
Right. When you found out that zero,
What do you mean?
All the zeros
All?
that we have, the zeros,
Yes.
they express what?
They express scenarios in which the other guy doesn't owe me money. I have 1,000 scenarios, okay? In some of those scenarios, the other guy will owe me money. In some of those scenarios, the other guy will not owe me money. I will owe him money.
Okay.
Since I'm interested in a credit event, okay, me owing him money is credit neutral. I'm just not worried.
His credit. In his credit. The credit risk at all.
Exactly.
If
It's
he
his
will
credit.
be able to pay me.
No, if I owe him money, it's if I will be able to pay him.
Yes.
In my view,
We are interested in if he is gonna.
exactly.
Oh, okay.
So those zeros are the scenarios at which I'm not interested.
Okay.
If this scenario materializes, okay, if this scenario materializes and he defaults, I don't care.
Τα μπορούμε αρνητικά.
And the formula that you gave us, that we need to compare the average with this formula, is something that each time changes. We use it approximately with what we want.
This
with our
formula,
goals.
this formula has to do with this being a very simple transaction. This is essentially dependent on one risk factor. And it's the simple difference of that one risk factor minus its central value, at the money. It depends on how much a dollar is worth, and my mark-to-market is simply the difference between how much these dollars are worth and the euro amount I thought they were going to be worth when I started.
Can you say that again one time?
What's my risk factor here? My risk factor is just the FX rate. Okay? What's my mark-to-market here? My mark-to-market is simply this. Okay? So
My mark-to-market is the ability of the other guy to pay me if he owes me money.
exactly, but on the average, what's my mark-to-market going to be? Expressed this way. On the average.
The average I found is the average of all of this list.
Exactly.
Of the times that that he will have to pay me. The average money that he will have to pay me over the 1,000.
Yeah. Yes, exactly.
Scenarios.
On
Let's
the
say.
average then, suppose I replay, suppose I have, suppose I replay this experiment, okay, many times, 1,000 times, okay? And suppose that these guys, my counterparts, they've got a 5% probability of default, okay? So, in many of those times, this guy is going to default, about 50. In some of them, this guy is going to default and he will owe me money. I choke up a loss. Some of them, this guy is going to default and I will owe him money. I choke up nothing. Nothing. I still owe him money. I'll pay his estate, his trustee money. What I'm trying to find out is, on the average then, after I play all these experiments, how much is the cost of the other guy's credit risk, which is simply the multiplication of two things. The average exposure, the way it's expressed here, we found it. This is the average exposure. On the average, the exposure in my first year is going to be 4 million. If I take a simple expected sum of all the scenarios, if I run 10,000 scenarios, it would still be 4 million. Just be a little more stable.
The probability of the other guy defaulting.
It's the second step.
Ah,
It's the second step. Remember, we said right now, I only found the exposure. We don't have the formula. I'm interested now in the probability that the other guy defaults in the first year, that he defaults in the second year, that he defaults in the third year, in the fourth year, and the fifth year. Okay? The more volatile a transaction is, given a counterparty, the more I'm worried. If my volatility was 1%, I would be a lot less worried because he has the same probability to default, but he's going to owe me a lot less, statistically speaking. This being 10%, I'm much more worried with a counterparty that has a 5% probability of default than a counterparty that has a 0.5% probability of default. Okay? This being, all other things being equal, are much more worried about a 5-year transaction than I am about a 1-year transaction. Why? Not only in 5 years I have more cumulative chances of a guy defaulting, but as this whole thing opens up, as you found here, the average exposure increases. So in the 5th year, okay, his default, chances are, will hurt me much more. Why? Because the transaction will have had more time to go out of the money, to go into the money, actually, for me. As the euro-dollar opens up as square root of t, you know, the random process, I have more time to accumulate uncertainty. Accumulating uncertainty means, look at the typical mark-to-market here, okay? 12, 9, 57. You didn't have these numbers here. Okay? This is the square root of t. This is this. This is this term here, which builds up the numbers in the 5th year. Okay? So you see, if he defaults in the 1st year, I'll have a lot less to worry about than if he defaults in the 2nd year, in the 5th year. So
the probability of defaulting is increasing over the years.
Cumulative, yes. The hazard rate need not increase. You remember when we talk about defaults. Every year, he has the probability of having defaulted until the year before, plus some finite probability of defaulting in that year. He cannot undefault himself. It's exactly the same. You know, take myself. Every year, I have a slightly greater probability of being dead. So my cumulative probability of being dead increases with time. Because it's always the probability of being dead up to time t, plus the probability of being dead in time between t and t plus 1. So, how would we go about finding the probability of default for each year? We said, if you remember, yes, please?
1 minus d times the hazard rate.
Exactly. Exactly. So, we would say, in 1 year, what's the probability? We say, the statement in here is the following. We are saying, and it's not expressed very well here, I say, client probability of default is 5% per year. What I should have said, and in an exam it should be specified explicitly, client probability of default each year is 5%. Actually, given that the client is solvent at the beginning of the year, he has 5% probability to default within the year. Which means in the 1st year, how much probability of default he has? Obviously, 5%. In the 2nd year,
95.
One minus.
it's 95% times 5%, okay?
95
Times 5%. In the 2nd year, actually it's easier to say the opposite. When you do the 2nd year like this, it's easy, but after that it gets complicated. And we do it like this. How much probability does he have to be alive in the 1st year? Alive. In the beginning of the 1st year, it's 100, okay? Year 0, year 1, year 2, 3, 4, 5, okay? 100%. Okay? How much?
This is at the beginning.
The beginning. Okay. End of year 0, beginning of year 1.
95.
95%. End of year 1, beginning of year 2? 95 squared. This, 95% cubed. 95% to the 4th. 95% to the 5th. So my probability of default each year, it's
One
the
minus.
difference between those. What? No, it's not 1 minus. For each year, it's the difference of being alive at the end from being alive at the end of the previous year. So here it is 5%. The PD within that year is 5%. This is 95% squared minus 95%. Which is that? Remember, it's 95. This is 95% cubed minus 95% squared. And so on and so forth. So, essentially, you find the probability of default like this. Yeah, go ahead.
Δεν θα πρέπει να είναι 95% μείον 95% στο τετράγωνο.
You're right, yeah.
Α,
Because this is a negative number.
ναι.
Yeah, you're right. It's 95% minus 95% squared. 95% squared minus 95% cubed. And no, I wasn't trying to see if you're paying attention. Just a stupid mistake. So it goes on like this. So you do this, and you have the probabilities of default for each year, which is not 5%. Okay? Again, this was a careless way from you. And then what do I do, my last thing?
Okay, compute the CBA.
I compute the CVA. How much is the CVA? By the way, this is a real problem. I mean, some time ago, you could be hired for a lot of money in a bank by just knowing to make this calculation. I mean, now you have machines doing it. But it was something. So, roughly how much is the CPA? Όχι, είναι 1000 σενάρια, δεν είναι 1000 χρόνια. Ο χρόνος είναι απλός. 1000 scenarios. No, you don't do it. You do it for 5 periods, not for 1000 periods.
Πίσω,
Όχι, δεν χρειάζεται να αρχίσουμε. Θα πάρω τα 5 πρώτα.
You want to take a break for like 10 minutes?
or
Either that or we continue 20 minutes again.